We'll wait for 5 more minutes for more people to join, then we'll start. Good morning, everyone. Today's session will be taken by Aniruddha Kumar. He is a student in our university, VIT Bhopal. He is the General Secretary of AI Club, the club that represents artificial intelligence and all work related to that in our university. And he is a very well experienced data scientist. He has worked with us for all of our current projects in Omdena VIT Bhopal, and I would say he was the top 10 contributors in both of them. His Our today's topic is Google Earth Engine, and most our both of our projects involved satellite imaging, and basically scanning the satellite images to get different type of values and parameters, right? So he will today he will teach us how to implement GEE with Python, and how to work with GEE in a controlled environment. Thanks. Anirudh, you can take the stage.
Uh, Thank you so much for such a lovely introduction. Am I visible and audible?
Yeah, yes.
Yes,
Okay, so hello guys, hope you are doing well. So as Iman said, I got to know about the GEE, that is Google Earth Engine, through the Omdena project itself. And uh, before starting the session, I would say that first, if you have any question, do let me know about it. And it would be better if you can ask me, because if you put it in the chat, then I may not be able to answer it right away, though I will address it at the at the end of the session, workshop. And then this introduction of Google Earth Engine will basically let you know about the overview of the Google Earth itself. And then you will be able to answer some questions that when we start a project, you will have like, what kind of parameters should I select? How should I access Google Earth Engine? What is the area of interest? What is features and their collection? What are the normalized differences? These types of thing you will be able to answer by yourself. For example, like you want to access the water management system of your area. So whether you should consider the chlorophyll or not, whether you should consider suspended matter or not, which kind of band should you be using, such kind of things you will be able to answer very easily. So yeah, let's start the session. So as I mentioned, we will be having we will go through the overview of the Google Earth Engine. Before that, we have basically three satellite space program, that is Sentinel, Landsat, and MODIS under the Google Earth Engine. So Sentinel, Landsat, and MODIS are if you basically, let's say Google Earth Engine is working from 1984. So the camera that we had in 1984 was not much great compared to what we will have now. So the zoom, the details that we have in a picture, or how many a single pixel contains how many meters of the um, land, that area of interest that you are having. So such kind of things has been developed. So under the Sentinel itself, I will explain a single satellite, then we will know about the other on your own. You can just go ahead and explore it. So before that, let me give you GE introduction a little. So yeah, so basic interface of Google Earth Engine is somewhat this. We have basically overview, then code editor where you can use the JavaScript, and then the documentation. Google Earth Engine is not only based on JavaScript, it has also collab with where you can use Python, and the REST API where you can easily make an app and something. Then we have the data set, non-commercial and commercial uses, time lapse, case studies, and similar FAQs and get started. So then this is the basics. So let's move with the data sets. There are a lot of data sets captured by the Google Earth Engine because it is actually working from 1984. So on a like if you want to go for climate and weather, so surface temperature, climate, atmospheric, weather for the whole world, for a specific area, for Africa only, for uh, North America, or any other continents, you will have these kinds of a lot of data sets, which we basically call the derived data set. And then we have the imagery through Landsat, Sentinel, and MODIS, and some high resolution imagery. How much high resolution it would be, we will find very soon. And then some geophysical, for example, if the terrain has been changed, deforestation, forestation, you can identify land cover, population, the city making, and all. Is the population rising? So if the population is rising, so the electricity in that particular area will be consumed more. So more night views or light will be reflected on the satellite. Such kind of thing you can explore. So let's go with the Sentinel. So here, if I click here, so yeah, this is the Sentinel collections. So here you can see that this is under the Copernicus program, and headed by the European Commission with the European Space Agency. And the Sentinel have basically Sentinel 1A and 1B, which is about all weather radar images, and Sentinel 2A and 2B for the high resolution optical images. And then ocean and land data suitable, you can find it through the Sentinel 3, and then air quality from the Sentinel 5P. I don't know about what happened to the Sentinel 4, but okay, moving ahead, we have Sentinel 2 multi-spectrum instrument. We will go with this. So yeah, in the Sentinel 2, you will see that it is wide swath, high resolution, and multi-spectrum, and global 5-day revisit frequency. So it would be going over the Earth in every 5 days. So there is surface reflectance and top of atmospheric reflectance. Now, as I said, if you are accessing a data set that was presented in 1984, so even though image quality is not that great, but if you are accessing the pollution, if you are accessing the atmospheric change, if you're accessing the basics like ozone depletion and such kind of thing, so you might be able to get through those data like comparison somewhat. The exact pixel of or the flower in the 10-meter or 20-meter of the land won't be there, but some atmospheric condition you will be able to get. Now, if we see the dataset availability for surface reflectance is from 2017 to present and 2015 to present for the this level 1C orthorectified. So if we go to the surface reflectance, you will see that this is harmonized satellite 2. Now remember the word this harmonized. Uh, Now the data set availability from 28th of March 17 to the 28th of October 2023 means the yesterday data is also here. Then this is the dataset provider and the Earth Engine, how you would initialize the satellite in your code. So the description is here, you can always read it. Then this is one of the most important thing that you should remember. Not every single parameter, but just have an idea. So if you go with a band 1, band 2, these are the bands. So every space program, let's say under some satellite, we have Sentinel, and in the Sentinel, in the camera itself, there are some band which will detect some particular things. For example, B1 will detect aerosols. B2 is basically detecting the blue color. Then this is green color, red edge 1. Just remember this red is B4, red edge 1 is B5. Just have an idea for now. This will be very helpful for the further discussion. Then this is NIR. NIR is near infrared. And then this is SWIR, which is short wave infrared. And similarly, all these bands are there. Now, we can't remember every single band for every single satellite. In the Sentinel itself, we just observed that we have 5 satellites. Then similarly, we have in MODIS, similarly, we have in Landsat. So that will be very hectic. So just remind yourself of this. We will move forward. Now, there are some image properties. For example, this high probability cloud percentage, it is telling us that it will give you a double, and the percentage of pixels classified as high probability clouds is there. Now, this is azimuth angle, zenith angle. So anybody tell me about zenith? Are you aware what is zenith? So let's say I will explain. Zenith is basically the topmost point above you, any spherical body in an astronomical way. So if you want to access for the area of interest that you have, that exact angle above that, then you will have to use the mean incidence of the zenith, and that is angle for band 2. Similarly, this is for band 9, band 10, azimuth angle is there, and a lot of parameters are there. Up to you will have to find out what exactly you need. Then we can have this terms of use. You can just read it if you want. Now this is Python setup. You can copy it, or I will just explain when I will be explaining code. And then you have the code editor for the JavaScript. So the code editor is basically integrated in the GE itself. So you can just go to the code editor and write the JavaScript code if you are very good at JavaScript or have some knowledge, or you can just use the Python because we will be doing most of our things in the Python itself. Now, if I move to, then we have points of discussion that we discuss about the bands, image properties, little about the satellites. Yes, datasets present in the GE and derived dataset. Derived dataset, if I tell you more, then let's say for all over the earth, you won't be selecting whole earth for your project. Let's say we want the Algeria. Then in the first we will go to the African continent, then find the data set for the African continent. Then under the African continent, we will go to the Africa. Then we will select the Algeria. Then if we want to select some particular cities or particular things, then we will select that. These are being derived from the major data set. Now, Google Earth has already some derived data set, and you can just go and access or find about it whether these derived data sets are for me or not. And browsing by the tags, I will explain. Let's say browse by tags here. You can just come here, you can 3 hourly data, accumulation, Antarctica or aqua data, then atmospheric data is there. These tags has been done. So if you go to the view all data sets, let's let it load. So here in the LN Coral Atlas, some ocean and Sentinel 2 derived dataset is there. Then if you are finding about the Australian, then Australian dataset, Australia, DM, elevation, these things are here. So according to the tags, you can also search. Then we have some key concepts in JE. That is, if you want to understand basics of JE, then you can just go here and read about it. So how the code editor will look like, you can find it here. Then all the satellites that has been there, the data set that has been there, you can see here. Then the architecture of the Google Earth engine is here, and some operations are there, but not every operations is here because I just go through it, but I didn't find many operations. But somewhat upper view you will get. And then how you get the data, basically Landsat you will access through you will load the collection, then filter out, then take the median, because let's say you are accessing, for example, 5-year data and you obtained around 200 images. You won't be, it will be very hectic if you just go through for each image, you will have hundreds of data. So what it will do, it will just select the median of that particular single image, and then it will give you. And then image dot subtract, if you are basically selecting the area of interest, it will subtract it and then provide it to you. Then inbuilt apps, it's quite interesting. Through the code editor, that is JavaScript, Google Earth has some apps. You can also make your own app. So here you can observe 4 zones. So let's just search Bhopal, and in the Bhopal you will see some points. So here just observe that natural color is given by the band 4, band 3, band 2 of what? Of Sentinel 2. And then color infrared is being obtained by B8, B4 and B3. Whereas if you want vegetation, then you want to access B12, B11 and B4. And for land and water, you will access the B8, B11, B4. So somewhat similar way, this is very basic. You will only able to visualize it. But if you go here, Bhopal is also known as city of lakes. So this is the upper lake, the biggest lake in the Bhopal, and the small sea dragon type structure is basically the lower lake in the Bhopal. So you can play around with the data sets and the apps. Then if we move here, so we have geometry and regions of interest. So as I mentioned, you won't be selecting the whole earth for your project because it will take actually a lot of computation even if you go for the whole earth. So we will go for a certain region. Now, how do you select these region? First thing is that you can directly take, go through the satellite and just select the predefined data set, or you can go for code editor in the JavaScript. In the JavaScript, you can write the code, or you can make the shape file. I will tell you what is shape file. And then or you can just pick a point, and then through the point you will be able to analyze. But the point, what point will do, for example, for New Delhi, let's say. So if I took a point single for, then it will take the whole area median, and then it will give the parameter that you want. So it's median. From the start of our project we are taking the median, so it won't be much better. So what we can do, we can just select the polygon, we can make the polygon, or we can just define in the Python itself how it will be done. You will see all these things in the code. Then filtering and mapping, I will tell you. Now, as I mentioned, that we have a lot of bands, like band 1, band 2, and these bands are present in each satellite. So if a single satellite is having 30 bands, how many satellites are there? You just saw in the side Science Direct also. So it won't be possible for us. So what researcher and people did, that they made some generalized concept, which is basically normalized differences. So these normalized differences is basically taking some bands, subtracting, adding, making some formula out of it, and from those bands we are getting the vegetation data, the snow data, indices for the snow, indices for the water, and then we have some more derived indices from the major indices. So if I explain you that we have normalized difference in the chlorophyll index. So what is that? This red edge one, if you remember, it was band 6 or band 7, and we are subtracting it with the band 4 or band 5, something like that. So in the code we will just specify the band, but what actually those bands are showing is this red edge one minus red divided by the addition of these things, and through this we will be able to get the chlorophyll. Now, if you go the app visualization that I told you, every single vegetation was having B12, B11, and B8, I guess. So you won't be able to just select B8, B12, and B11 for the visualization, and then you might forget something. But if you use this, what will happen that for an area of interest in the lake, you want chlorophyll. If through this you will get an output, and by that you will be able to analyze that, yeah, if chlorophyll is very high, this means that the water is not clear, it is dirty, because algae is there. And yeah, one point we should remember, that NDCI only tells you about the chlorophyll A. There are two types of chlorophyll, chlorophyll A and chlorophyll B. To know more about it, I have attached the references here. When the PPT will be shared to you, you can just go through it. Then now we have normalized difference in the vegetation index. How much vegetation is there? If you are if you are doing analysis for that forestation, deforestation, or afforestation for a period of time, or if you are doing analyzing that how much vegetation, how much crop field is there, and somewhat on the lines, then you can use this parameter where this NIR, that is, I told you, near infrared band minus red band, divided by near infrared band plus red band. So through this you will get the vegetation index. Now if you observe, chlorophyll should be derived from the vegetation index, and that is how it is. Then we have this normalized difference in water index, and in the water index itself, the same small wave infrared index, yeah, short wave infrared index is there. So through that subtraction and addition, you will able to get the water index. Now the derived form of the NDWI is MNDWI. You can find it about it. Then here is also, I have attached the references. Then this is the resource. You can go to the YouTube and watch it. Then if you want to know some spectral indices, more about these spectral indices, then you can visit this, where MSAVI, modified soil adjusted vegetation index, then normalized difference vegetation index. Similarly, more indices are here. So you can just go through it. Not all indices are here. For example, if I search for NDWI, you won't find NDWI, but you will find MNDWI, which is basically modified form of the normalized difference water index. So you will have to read about it whether you should use it or not. Now let's go to the code explanation. And I will go to the code editor. So any questions up till now, guys?
Yeah, we can hear you. Good.
Okay. Uh, so what I have done here in this code, we are basically installing the packages, and the GIS system is here, installing the packages for the GIS system, then importing the necessary libraries, authenticating GE, mounting drive. I will tell you why we are mounting drive. Then satellite initialization. There are some factors to consider in the satellite initialization. Then we have ways to import maps or area of interest that I told you, through the point, through the list of coordinates, through the JSON file, shape file, polygon file. A lot of things are there. Then initialization of any normalized differences. So I am taking the normalized difference for the chlorophyll index, making a data frame visualization of the distribution, obtained values with respect to years. We will just see it. And then we have the visualization layers of the layers and AOI. So I have already made the NDWI parameter and the surface reflectance parameter. You can just do a lot of things with it. So we will install Gmap, and this isGhydro, and this is PyCyrus. PyCyrus is basically GIS initialized for the Python. So many plotting and other things you will be easily able to do with it. Yeah. So now we have this Gmap, then PyCirrus, Folium. Folium is another part to plot the map. Then date time and pandas, NumPy always should be there. Then date time as dt, and then you have ipython.display. Now we will authenticate the GE. So yeah, you will just click on this and then sign up. Before using this, you will have to sign up in the Google Earth main site, and through that then you will get the access. It will ask about what kind of organization you belong to, why are you doing this project, what is your aim, and so on. Some things will be there. Now when you come here, then you have to either make a project. So you will basically go and create a new project here, select the organization, no organization. You can make your own visible ID and other things. Since I already have a project here, so I will just select my existing project, and then yeah, done. We will generate the token, accessing it through my ID, and we will have the token here. Though it is said that you should not share your token with anybody, like I am doing right now. But yeah, be sure about it. And then, yeah, before mounting it, I will tell you about the shapefile. Mm, yeah, so I will access the code editor. Yeah, so this is the JavaScript code editor. So here you have the script. Whatever you have made up till now can be shown here, like Jawaharlal Bal Udyan Lake and Lower Lake, Manit Lake. These were from the Bhopal project. And then we have some docs for the JavaScript. Then the assets under the, you should add whatever project you are making in the asset. Then here you will write the code. If you want to share the whole code, then you can just share the whole code with us, copy paste on the Slack. Or you can generate a link for this code and then share it with us. After writing, as usual, JavaScript needs you to save it, then run the code. When you run the code, it will be shown on the console if you are plotting something, or if nothing is there, like if you are not printing anything, so nothing will be shown on the console. But yeah, if you are giving a task, let's say soon we will give a task. So in the task, you will see the submitted task should be there and unsubmitted task will be there. So, and this is the map. So if we go here in the Algeria, how we can make a shapefile. Let's select this lake. This is Barrage di Doera. I hope I am pronouncing it right. So here is option for drawing a line. Then this another option is for a shapefile. You can just make your own shapefile like this. You will need to select the whole lake. If you want exact points of the lake or only the lake, then you can just make your own polygon around it like this. And soon the polygon will be there. The another method is basically selecting the rectangle. So this is the polygon that we made, or you can just make the rectangle itself like this. It will cover a lot of land, but if you are going for the land and water both, then it is fine. But if you are just going for the water, then these land will give you some output. For example, if you are using the ndwi or vegetation index, so the vegetation for the land will also be present in the data. So it's better to make a shapefile or just give the coordinates. So if I go here, the geometry one is the polygon, which has 43 vertices, and in this vertices we have these longitude latitudes. So you can just copy it, and in the geometry, since we made a rectangle, so it has only 8 vertices, and the coordinates are these 5 elements in the list one, and this 5 element as a list 2. So I will just delete the geometry 2. Now a simple code is there. I will write it. So we are basically making a collection variable in the JavaScript, and then through the Earth engine, we are telling it to collect the feature of AY. AY is here geometry. I'm just changing the variable name. So for this polygon, I want to collect the feature and export it to the drive, where collection should be this variable collection, and then description is Algeria Lake, folder is Algeria project, and the file format is shp. Now I will save it and then run the code. When I run the code in the task, you will see this unsubmitted task. You can just run it, and what it will do, it will just make you a drive folder such as this. Now in the my drive, you will see this Algeria project, and in the Algeria project you will see the SHX format, SHP format, PRJ, FIX, and many formats are there. We only want the SHP format. Just ignore this CSV file. I will tell you why this CSV is here. So now you will know why we want to mount this drive, because we need to access that SHP file. So we will connect it with my drive, and then I hope it will be mounted soon. And then we are basically giving the path of that SHP file here. Yeah, and if you don't know, then you can just go to the drive. Will be there in the drive. Algeria project is there, and then you can just copy the path and just paste it here. in this variable. And then we are basically initializing the satellite. So Sentinel we are using with Sentinel surface to surface reflectance. If you remember, there was harmonized word there. We are not using the harmonized word. Let's see what happens. And then we have this filter dot filter, where we are saying that we want cloud in the photo less than or equal to 20%, and the date is there. Why I have selected only 20%? Because 20% is somewhat sweet spot. Now, we remember that the Sentinel was from 2017 to 2023. Now, let's see whether I have written the 1 January 2015. Uh, let's see what happens. So, we will initialize the satellite. And then, as I told you, this is another section where ways to import the maps. So here, using shapefile, point selection, and list of coordinate. So this is basically list shapefile. I am initializing the gmap, then lake AY is being shapefile, shape to EE, Earth Engine, as a lake, and then adding the layer. Here in this bracket, if you want some bands, then you can add the bands, or you can just leave it at is it. And then I am center object, where I am telling it to center my map, not show the whole map. Now let's see our selected area. Here is the Doera Lake. So as you can see, we can see our shapefile. Now this is initialization through shapefile. Now what you can do, you can just select the polygon. Either you can select every single aspect, that 43 vertices, or you can select the rectangle. So for easier work, I have just selected the whole rectangle. And then here I am telling it that this is a polygon geometry, and under this, these are the vertices. If you want to use the point, then just change polygon to the point and give the single longitude, latitude. And one point you should remember, that if you pick a point from gmap, then it will be in the format of latitude longitude, not longitude latitude. So the Google Earth Engine basically initializes things in latitude longitude format. So you have to think whether the format is right or not. So for example, when we were doing the monitoring water project, so we were giving the Bhopal longitude latitude, and we are getting something on the lines of New York, and we were just doing what is happening. And then we got to know about it, that the format is different. And then here I am using the Sentinel and taking it to filter it using the bound as the lake AOI poly, and then print it. So yeah, you will get the information what has been done. Yeah, so image collection is there, type is image collection, ID is Copernicus, version is there. I have used no band, so no band is there. Properties, there are 21 properties, description and all, and then the list of the images. So moving forward, we will see how many images we have. So it says that from 2015 to 2023, we have only 197 images. That means we just observed that the satellite goes 5 days in surrounds the Earth in 5 days. So and we are still getting only 197 images. Why? Because the image quality, we have told the prompt that it should be around less than and equal to 20%. If I change it to 5%, let's see how many image we will have. And you will observe that in the span of around 8 years, we are only getting, okay, first I should do this, then okay, 125 elements, and we are getting 125 images. So in the span of 8 years, we have only 125 images. Now we will go to the initialization of normalized difference. I won't run this code because if I run this code, it will take around 10 to 15 minutes to run. But what I have done, I will tell you, because here I have made the function, and in this ndci variable, we are telling the image to normalized difference, take the normalized difference of the band 5 and 4, which is ndci, and then return the bands. With ndci, we are initializing it with the map of the satellite, that is Sentinel, and then we are taking the mean of the Earth image, and all these things are here. And yeah, best effort, always true. Max pixels, scale, geometry, all things are here. And then we are basically taking, converting it to the list and making it in this list, adding all the columns, this temperature ndci and ndci column append, all these things is being added to this column. And then we will make a data frame, and we will make a data frame, and then import it as the chlorophyll csv. So what is this chlorophyll csv? This is, so it took around 15 minutes to get chlorophyll for only 197 images for me. So if you take whole data for a very bigger uh, area of interest, or a very bigger country you are taking, or if just I said that earlier, I said that if you take whole earth, then the computation will be very, very long. And yeah, we got the data from 2017, as I because Sentinel 2A is from 2017 to 12th 30 December 2022. uh, okay, now we will see the visualization of this distribution. So how this distribution is now, if we observe, usually chlorophyll should be between minus zero point 0.1 to zero point 0.1, but this is giving data for minus 0.2, 0.3, 0.4, and negative 0.5. But frequency is very low compared to this distribution. Any questions?
بس كنت باغي ندخلهم في البيت روح عشان نحكي معك كنت
Okay. Uh, Kyra, your mic is
ريح بركة ما نحس اسكت
Dr. Khaira, your mic is open.
okay. Okay.
so
Thank you.
sorry yeah so
Uh,
sorry
Okay, so here in the chlorophyll, you will see the frequency distribution we are seeing, and we are observing that most of the data points are between negative 0.1 to 0.1. Now, if we will observe, so the same pattern is being shown from 2018 to 2019, 19 to 20, 20 to 21. And somewhat this is pandemic period. So either it is because of the pandemic, or the weather and climate of the Algeria, of that particular lake. I don't know. These kind of thing we will have to find and analyze, which is quite interesting, because in our project also we weren't able to get any data for the June, July, and August. Why? Because India has rainy season in that particular month. So it was quite interesting. It is always interesting to find these things. Now, if we will visualize this, so here in the Algeria, you can, what we did with the JavaScript, we can directly do it here. So I will select this whole area, and now we want to make a visualization. So here you can this is the toolbar, and in this toolbar you will observe that inspector is there to inspect something, plotting something. Then we have the create time lapse, and many other options is there. For example, this is the change base map. For let's say in a country you have a new state, or some border has been changed, a new city has been formed, something similar is happening. So it will be, you will be able to select those things through these maps. Then you can see the earth engine, converting earth engine JavaScript to Python, and many other things. are there. So let's make a time lapse and minimize it. So yeah, in the collection you will see that Sentinel, Landsat, and Modis, we have 3 satellite. Then you can whatever you want to put here. Then in the RGB you can select which kind of band you require, and then frame per second is here. Progress bar should be in blue color and or any other color. You can just select start year from 1984, so it would be quite long. Just select 2010 to the end year of 2023. Start month from January or any other month you want to select to the end month of December. Well, since November has not been started, so it should give data around October of 2023. And then font size you can select. Now you can apply mask if you want, like remove cloud, shadows, and snow that is mentioned here, and then normalize different index if you want any. So let's just select the vegetation index, and it will give you the band by itself and create the time lapse. When it is creating the time lapse, let's observe these things. This is NDWI parameter. I guess you also observed this in the presentation itself. So this is how the water is being reflected to the satellite. So what actually happens is basically if we take vegetation index or a snow index. So I just wanted to play around, so I also selected the normalized difference for the snow index. But what happened that it gave me data, whereas I don't think so Algeria has any snow falls. So what actually happened is that light fall on the water or any other things, and then what satellite basically observe, it basically observes the reflectance, and it doesn't know that it is a snow or it is a water, it is something else. We form those abstractions, and then according to those abstraction we understand it for ourselves. But satellite is just observing the surface reflectance. So if there is some surface reflectance, then you can also observe snow in an area where there should be no snow. So this is the water index from 2017 to 2023, whereas the frames are around 8 frames per second. And now this is surface reflectance time lapse, and this is from 2017 to 2023. And now let's just observe this, the vegetation index, save it, and if we see, this is the vegetation index, which is basically showing the area of the lake. And I guess when the lake is being minimized or it is being covered, it is showing that the vegetation in that particular lake has been increased quite a lot. That's why the water is shown very less, and the other parameters are shown. As the time moves, the water in that lake is being increased. So such kind of inferences you can observe. And the point I was saying for the presentation, here you can observe the snow index. Yeah. So this some reflectance was shown, and those reflectance is being denoted by this GIF. Yeah, so that's it from my side. Guys, if you have any question. No question in the chat, I guess.
I have a question.
Yeah,
Can I-
please.
Okay.
Yeah.
I am wondering to know about the selections of area of interest. For instance, if you want to know the water level extent in a certain lake, for instance, if it is vary annually or seasonally, what are you going to say? Like, are we going to consider the rectangular one or based upon the shapefile?
It's up to you. If you are selecting for example, you just want to analyze a single lake, then you can just go ahead and select the area of interest of only that particular lake. Because if you select a rectangle, then some land will be there also. And when you analyze it, when we take the median, so it might since median is also a central tendency, so you know about the effects of the central tendency. So it's better if you are analyzing only a particular thing. But if you go for a country, whole country, then yeah, you can only you should consider a rectangle. It would be much better and easier for if you put a single coordinate and vertices over the boundaries of a whole country. That will be very, very tough.
Thank you very
Does
much.
that answer your question?
Thank you.
Okay. Any other question? Yeah, they are quite complicated, but if you not much complicated, if you just start using the GE, you will just get a grasp of it. It's not that hard. Yeah, pleasure is mine. So, anybody? If not, then Iman, over to you. Yeah, I will share the presentation code, everything.
Yeah, the presentation was amazing. Thanks a lot, guys. Kyra, do you have anything to say?
Yes, and thank you very much, Iman. Thank you, Aniruddha. It was a really a great explanation. And really, I am so sorry for the voice. Just
No
please,
worries, no
if you
worries.
have, yeah, yeah, dear participants, if you have any question, please do ask them. Yeah.
Guys, if you have any question, you're free to ask. If you don't have any questions, then just type no in the chat.
Yeah, actually, I have another question. Sorry, I have lots of questions.
Yeah, no worries. Ask.
Okay, can you please try to show us, like in the very beginning, when we connect the Google Colab with the Google Earth Engine? Because I was a bit working with the JavaScript platform in the code editor, but in that case, it is very nice interface. You can create legends and lots of things, I guess, in Google Colab.
Yeah,
In the very beginning, when you
yeah.
connect
In the beginning, what do you want? Can you
Go-
repeat?
Google Colab with Google Earth Engine.
Okay,
Colab.
how I am initializing it?
Yeah.
Okay, wait, just a second. I just minute. Yeah, is it visible?
No, it's no. Yeah, no.
Okay. So here I'm basically just initializing the libraries, installing the Gmap, and then I'm installing the G Hydro for hydro analysis if you want, because I used NDWI. And then the PyCirrus is basically the GIS system for the Python. And after that, we are basically importing the important libraries, authenticating the GE, and then if you are using the shapefile, then you need to mount the drive, and then you can access the lake. Then after that, through this variable where I have provided the URL of the path of the lake, then I am just using this variable to first we are initializing the satellite Sentinel, and this is basically the satellite that we are using. If you want to use Landsat, then you can just go ahead with it. some the initialization prompt for that particular satellite, you will observe it in the Google Earth documentation. Or you can just go to that particular satellite, let's say Sentinel 2A, then you can just select Sentinel 2A, and in the Sentinel S2 you can just copy paste it. Then I am taking the filter cloud percentage. There are a lot of filter like cloud pixel percentage, cloud pixels only, and you don't want it the percentage, so you can less than equal to. These kinds of functions are there, so you can just use it. And I am here telling it that I want the photos where the pixel percentage of the cloud is less than equal to 20%. Then I'm initializing the dates, and then this is the initialization of the map, and as a shapefile, if you want to see the shapefile that you imported, or you can use it from the list of coordinates here. uh, the list of coordinates from the rectangle or the polygon you selected, and then putting it in the Sentinel satellite, just getting how many images you have. Example of the NDCI, you can just you will for if you want to select NDWI or MNDWI, you just need to change these bands and a little bit in the function, and then you will be able to get anything. And then these function basically takes initialize the NDCI, and this function take the mean of the NDCI, and then it converts it in the list and adds it as a list. And then we, in the data frame itself, we are adding the dates, and then we are making the data frame and importing it to the Chlorophyll CSV. You will see the Chlorophyll CSV here. Though if you run and if you take a very big parameter, then this NDCI itself will take around 15 minutes. 15 minutes, 20 minutes, 30 minutes, up to you which kind of lake or how bigger is your area of interest. Then we have the visualization of the distribution that we obtained, and some analysis. And this is the visualization layer or the time lapse if you want to create. And yeah, the time lapse you can see as a GIF here I have put. Is it clear? Or should I explain something else?
Thank you very much. It was really very clear. Thank you.
You will have the recording also, so you can just go through it also.
Yeah, of course. Thank you. I really appreciate it.
Yes, Rabia?
You selected cloud pixel percentage as 20%. Why?
Yeah.
Why?
Okay. For example, you observed here that when we selected cloud pixel percentage to the 20%, it's basically a sweet spot for around 2017 to 2023. That is basically 6 years. We only obtained 197 images. Why? But we got to know that Sentinel satellite takes basically rotates around the Earth every 5 days. So there should be much more images, but we only obtained 197. Reason being that we told uh, to the satellite that you should filter out the cloud pixel percentage where only less than and equal to 20% cloud is there in the image. If I change it to the 5, then 5%, then you have observed, I just showed in the code earlier, you can observe that we will obtain only 125 images. Means that only 125 images has cloud pixels percentage as less than and equal to 5%. And why we are defining this, because let's say if you are observing the chlorophyll percentage or the vegetation index, then you will be able, you don't require uh, the atmospheric cloud, because these atmospheric cloud will basically play around with the data and will give you a lot of outliers. So 20% is somewhat a sweet spot. That's why I took 20%. That's it. Is it clear?
Yeah, it's clear.
Okay, I didn't authenticate it. That's why it's showing error. Okay, any other question?
Yes, thank you, Aniruddha. I think we have another question from Saeed. He was asking in the chat.
Yes. Okay, in the chat. The resources will be shared to you via Slack. Can we use the same concept with the Jupyter notebook? Yeah, yeah, you can easily use it. But for example, here we can actually see the functions that is happening. So first you will need to download all the shape files. Then you will need to download these parameters and all these gmap and initialize it in the Jupyter notebook, and then you will be able to do something. And just I said, like here you can see that when the code is running, so 7 minutes or 15 minutes has been utilized. You are just getting an idea, okay, it is still running. But in the Jupyter, you won't be able to, you will just have some thinking that how much time has been elapsed. It is not giving us any time and all. So it would be very hectic to your mind. That's why collab is much better, because I actually tried it with the Jupyter and faced this issue. Okay. Does that answer your question, Said? Okay. Sure. Then over to you, Amir.
Yes, adding to that question, is it better to use Kaggle in our case? Since, in my experience on the free versions of Google Colab and Kaggle, Kaggle resources from CPU and GPU are way better. What do you think?
Okay, so you can experiment it with it, but in the I didn't use it. We can always do an experiment and see how much faster we are obtaining the data points.
Okay, thank you.
Mhm. Any other question? Yeah. So over to you, Dr. Kaira.
Yes, yes, thank you, Aniruddha. So I think there is no more question. So if we have, yeah, thank you very much, Miho. Thank you everyone for joining. Thank you, Aniruddha. It was really, really very insightful and helpful to know about Google Engine, Earth Engine. Just to tell you, we will kick off our project very soon. Just be stay tuned on Slack. We will share the meeting links and everything related to the kickoff of our project. Okay. So thank you everyone, and really happy that you are enjoying learning with us. Thank you, Iman, also for your nice efforts. Thank you.
Yeah. Thank you so
Thank you.
much.
Thank you, everyone. Thank you, Kyra.
Thank you. Thank you.
Thank you,
See you
Aniruddha, for
soon.
the lovely session.
Mhm.
Thank you.
Thank you. See
See
you
you guys
soon.
soon.
Okay.
Someone asked for a Slack link.
Yeah, Amir, I couldn't get you. Once more, please.
I said someone asked for a Slack link in the chat.
Okay, yeah, Slack link. I will. Okay, I will check and send them by email.